Let's do like a mathy problem with this. So we have this inclined plane here. Oh, look at all that wonderful stuff that you don't have to do that every single time, by the way, that last video where I did the proof. In fact, what I really expect you to do on these inclined plane problems is you just draw the normal, you draw the weight, and then you want to use dotted lines to split the components out to kind of let you know that the weight is made up of the sine component and the cosine component. And again, that's multiplication. So when we actually want to set up the forces to solve for the acceleration in a problem like this, so we've got a 3 kilogram block and it slides down the plane at 30 degrees, and we want to get the acceleration. So we need to set up a vertical equation and a horizontal. And again, we mean with respect to our new coordinate system where vertical and horizontal are both a little tilted to suit the grade of the plane. So in the x direction, I have w times the sine of theta, and the effect is that it makes the mass accelerate. We know that because the block gains speed as it slides. Now, in this y direction, the normal and the cosine component of the weight, part of the weight, they have a tug of war. Nobody's winning. You don't see the block fly up into the air or crash into the plane and damage it. So let's actually put in our numbers and solve. So if you remember, weight is the mass times the gravitational strength, which is 10 meters per second squared, or 9.8, depending on whether you're doing a lab or whether you're doing worksheets like this. So we're going to have 3 times 10 times the sine of 30 equals 3 times a. And so when we actually simplify for a, we're going to end up getting 5 meters per second squared. This is the answer that we wanted, but let's just continue and do something that is true but not useful yet. So let's solve for the normal force. So I have the normal is 30 times the cosine of 30. So that's going to give me 30 times radical 3 over 2, which is going to give me 15 times radical 3. I suppose if I wanted to simplify that a little bit more, I think that ends up being something like 22 newtons or around there. We won't actually multiply it out. This is actually acceptable for the AP. Please notice though the units of forces are newtons, which is kind of annoying since normal force and newtons can get mixed up. So unfortunately, you'll have to see both on the AP, so that's why I leave it like that. So that's a number problem. In our next video, we're going to try to do things with variables only.